All right, so in this video, we're going to go through sample question 33 from the Society of Actuaries ExamP list of sample questions. I actually already started, I didn't realize I wasn't recording. I kind of wrote a few things here, but I'll get into that in a second. Not a big deal. So the question reads, the loss due to a fire in a commercial building is modeled by a random variable x with the density function given here. Given that a fire loss exceeds 8, calculate the probability that it exceeds 16. All right, so what is it asking us? It's basically asking this. It's a conditional probability where x is our loss. So the probability that x is greater than 16 given that x is greater than 8. So basic conditional probability formula would get us to this. The probability of x being greater than 16 and being greater than 8 over the probability x being greater than 8. And then I hope it's obvious that this numerator, if you're greater than 16, you must be greater than 8. So this second bit's almost repetitive. We just have it down to the probability that x is greater than 16 divided by the probability x is greater than 8. All right, now how do we actually go about getting these probabilities? So the probability, like the probability density function that it gives us here is not an actual probability function. I'm going to assume you're familiar with PDFs and CDFs and that kind of thing. This video would get too long if I had to go into all of that. So we're going to use the PDF, right, the density function, to actually calculate the probability. To get the probability from PDF, we integrate, right? So first, we'll work with our numerator, the probability that x is greater than 16. Now, that should be equal to the integral. Now, what are my bounds of integration? Well, they should be what I'm looking for the probability, like in between, right? Since it's greater than 16, I know my lower bound is 16. And based on the PDF, oh, hang on. I believe this question was somewhat cut off because this should say 20. Right, because this particular function has a max loss of 20. So my upper bound would be whatever my maximum is. In this case, it is 20. If it's not given, it would be infinity, right? And then what am I calculating? Well, that's in between this range, so I'm using this expression. 0.005 20 minus x dx. Okay, now I'm going to multiply this out. It's easier for me to multiply it out. So 20 times 0.005 is 0.1. So this ends up being integral from 16 to 20 of 0.1 minus 0.005x dx. And this is where all your Calc 2, Calc 1 knowledge comes in. How do we integrate this? This one's actually pretty simple. This is going to be 0.1x minus 0.005 over 2x squared. And we must evaluate from 16 to 20. Okay, and 0.005 divided by 2. I'm just going to kind of simplify that, right? Easier to write it as 0.0025. So evaluating that, it's going to be 0.1 times 20 minus 0.0025 times 20 minus 0.1 times 16 minus 0.0025 times 16. Oh, sorry, this should be squared. My bad. There. Okay. So let me just put this into the old TI-30. So 0.1 times 20 minus 0.0025 times 20 squared. That's going to end up being 1 minus here. It's virtually the same thing, but instead of 20, it's 16. And that ends up being 0.96. Okay, and the fact that this is 1 should make sense if you're familiar with how using a PDF to get a probability works. Okay, so this is going to be equal to 0.04, and that's our numerator. And I'll just put that here, 0.04. Now, let's get our denominator. This should be fairly simple, right? Same process, except we have slightly different numbers. Our loss has to be greater than 8. Okay, so when I create my integral, my lower bound is 8, my upper bound is still 20. And I have the same function from before, and we took the integral. The integral is going to be the exact same thing, just we evaluate it with different numbers. So it's 0.1x minus 0.0025x squared, and that is evaluated from 8 to 20. Now, we know from the first bit that evaluating at a 20 should get us 1, and this should be subtracted by this expression evaluated at 8. So doing that real quick gets us 0.64, and this equals 0.36. Okay? 0.36. And evaluating that fraction gets us 0.1 repeating, or 1/9, answer choice B. All right, so hopefully this problem is super clear. It's just asking us to calculate probabilities if we have the PDF, if we have the density function, you integrate over the range you want to take the probability of, and that will get you the probability of falling within that range. Okay, if this video helped you out, hit the like button, subscribe, because that definitely helps me out. If there are any questions, throw it down in the comments. I'll answer them to the best of my abilities. And if you want to see more worked out questions, I have a playlist. Go check it out. But other than that, good luck, guys.